In this lecture, we are going to discuss some sections of the chapter 8 and some sections of the chapter 9. We will focus in the periodic table, the valence, electron and ions, chemical bonds, and ionic compounds. We discussed last time the position of the elements in the periodic table is important, and when we study the electron configuration, we conclude that all the electron in the first group, they had one electron in the last shell. The elements in the second group A, they had two electrons in the last shell, and the elements in the group third A, they had three electrons in the last shell, and in the same way, this number on top indicate how many electrons these elements they had in the last shell. And also the periods, which are the rows, we can say are the rows in the periodic table that indicate the level of energy. In this, remember, this is n equal 2, n equal 1, n equal 2, 3, 4, 5, 6, 7, that indicate the main principal numbers, which is the energy level. In the periodic table, we can divide the elements in groups according to their properties. For example, the blue part of the periodic table in this case corresponds to the metals, the green one corresponds to the non-metals, and the orange one corresponds to the semiconductors. The metals are identified because they easily lose electrons. The non-metals, they usually gain electrons in chemical reactions, and the semiconductors, they may gain or lose electrons in chemical reactions. But one thing is, we can see here these numbers. As we will focus in the A groups. In this part, we can see this group has one electron in the last shell. This group has two electrons in the last shell. This has three electrons in the last shell. And because they had just three electrons in the last shell, this is why for the metals is easier to lose electrons. But in another hand, in the case of the non-metals, they had 7 electrons in the last shell. Then in order to be stable, they need to have the structure similar to the structure of the noble gas, this group A. Then all the elements that had this structure, this electron configuration, they are stable. And in order to have to the group 6 or to the group 7 have the electron configuration of the group A, they need to gain, in case of the group 6, they need to gain 2 electrons, because it's easier to gain 2 than lose 6 electrons. In case of the group 7, they need to gain 1 electron to get 8 electrons in the last shell. It's easier to gain 1 electron than lose 7 electrons. And this is why for the non-metal, they gain electron, because it is easier to gain 1 than lose 7 electrons in case of the group 7. Then this is why these numbers we had on top are very important and play an important role in the chemical reactions. We had also one more division is the transition metals. These are a little more complicated than these groups, and this is why here we don't have, this is B groups. Here are B groups, but again, for now, we will focus in the A groups. We will focus on this group and on this group. Then again, the metals usually they lose electron. It's easy for them to lose electron to get the configuration, the electron configuration like noble gases. And non-metals, they usually gain electrons in order to have the electron configuration of the noble gases. And let's move here. Then again, we will focus on these groups, on these two groups, on these four groups for now. Then the group 1A is the alkali metals. The second group is the alkaline metals. This is the group 2A, and they are they react with water to form alkaline solution. And usually these groups, they will react with the halogens group, with the 7th group. And the reason is the alkali group need to lose one electron to be stable, but halogens, they need to gain one electron. Then this is why these two groups usually react to form new compounds. Yes, because this need to lose one and this need to gain one. That is the perfect combination. And all this these elements, they react in order to get the electron configuration of the noble gas. Why? Because the noble gas configuration is the stable configuration. Yes, the stable configuration for the elements is when they had 8 electrons in the last shell, except for helium, which had 2 electrons in the last shell. Then usually what happens is metals react with the non-metals to form new compounds. One more thing I just want to review. Remember, the 6 here indicate the atomic number, and this atomic number give you the number of protons. And this is very important because the atomic number identifies the atom. Yes, if the number is 6, we know it's carbon. If the number is different, yes, it's 8, 9, 10, then we had different element. Then 6 identify what kind of element you had. Another thing we want to review is when we had neutral atom, the number of protons equals to the number of electrons. And also the mass number, which is usually here, the bottom, correspond to the number of protons plus number of neutrons is about this. Yes, in general, we can define the mass number is about the number of protons plus the number of the protons plus number of neutrons. Then here I just want to review again this why we said before. The number identifying the A group, yes, this number identifies the number of electrons in the outer shell, yes, in the last orbit, in the last shell, except for helium, because remember helium should be here, because helium, the properties of the helium is similar to the properties of this element. This is why it's here. But this number, yes, is telling you what is the number of the electrons in the outer shell. And why is important? Because the outer shell electrons are responsible for chemical reactions. Then we can also represent the number of electrons the elements had in the last shell or in the outer shell just using the dot notation. And here we had, for example, all these elements that are in the first group, they had 1 electron in the last shell, and this is why we had just 1 dot. This group, they had 2 electrons in the last shell or in the outer shell, and this is why we had two dots here in all these elements. And in the same way we had for the other groups, as we had for the other groups, helium, we even though helium is in the group, in the A group, yes, it's in the group 8, but we know this just has 2 electrons in the outer shell. But the other one, they had 8 electrons, and this is why we had 8 dots. And here is the stable configuration. And again, we want to review this one, the 1, 2, and the groups that had 1, 2, 3 electrons in the outer shell. Is 1, 2, 3 electrons. Usually they lose electron and became positive ions. Yes, and that happened in metals case. Yes, for the metals, they usually lose electrons and became positive ions. But what happened with the group from 5 to 7? From 5 to 7, this is mainly belong to the non-metals, and usually it's easier for them to gain electrons, to be stable, and become negative ions. And this happened in the non-metals, as mainly in the non-metals elements. And the semiconductors they are intermediate between metals and non-metals. Then we can use the electron dot configuration when we are working with the chemical reactions, and when we are also to understand how we can form new compounds. We can use the dot notation to indicate the number of the electron in the outer shell or in the last shell. Then why this is important, the electrons in the outer shell? Because the chemical behavior is determined by the outer electrons. These electrons are called valence electrons. These outer shell electrons are represented using electron dot diagrams. Also, it's called Lewis structure. Yes, we can represent the outer shell electrons using the dot notation. Another thing is important is the noble gases had complete filled the outer shells and are therefore stable. Yes, this is why the elements in the group A, they are stable. They have the outer shell is filled. All other elements, all these elements, they react so as to their fill outer shell and become more stable. And they want to fill this one. Yes, to be stable, they need to fill the outer shell to have the similar electron configuration as the noble gases. Yes. And let's now talking about the ions we discussed last time, but let's review again. Yes, in this case, what we had lithium, and lithium, let's check what happened with lithium. Lithium has 1 electron, is the number 3, yes, lithium, and lithium has 1 electron in the last shell, as is indicated here. Yes, lithium has 3 protons, 3 neutrons, 3 protons, 3 electrons. But to be stable, to be similar to helium, lithium needs to lose 1 electron. Yes, like this is represented here as lose 1 electron. And if the lithium lose 1 electron, then now became positive 1. Yes, positive 1, because lithium has 3 protons, 2 electrons. Then become positive 1. Then we can represent the positive 1 like that. If there is no number we know it's positive 1, just you can write positive 1. Then this, when this happens, this is in this case we don't have lithium, we had ion of lithium. Yes, in this case we had ion. Then this happens usually in metals. As metal lose electrons to become more stable. Now let's check what happened with fluorine. Fluorine is how many electrons in the outer shell? They have 7. Yes, it's this one. Now, in order to be stable, fluorine needs to gain 1 electron to be like neon. Yes, then fluorine gain 1 electron to be like neon. But what happened with the fluorine gain 1 electron? Then the fluorine has 9 protons, but because gain 1 electron now has 10 electrons. And we can see here, yes, then the fluorine will be the net charge will be -1. This is why here the ion is indicated. This is the neutral element, but here we have the ion of fluorine and it's +1. And usually that happens in non-metals. Yes, usually, and the metals are always positive ions and non-metals are negative ions. Then metals lose their outer electrons to acquire a noble gas structure and became positive ions. And in this case we had cations. Yes. But what happened with the non-metals? Usually what happens is the non-metals gain electrons to be more stable. Yes, to be more stable and became a negative ions or an ion. Yes, it's called an ion. Then what important thing here is metals are positive ions and non-metals are negative ions. One more example here. This is case of sodium, and we know sodium is a metal. Is here, yes, sodium is metal. Then must be a positive ion because it's a metal. And what we can see, what we had here is the electron configuration, and we can see in the third energy level, the sodium has 1 electron. Yes, and it's easier to lose 1 electron. Yes, if the sodium lose 1 electron, lose this. Yes, if you lose this electron, then became as neon. Yes, became as neon, which is a stable configuration. Then if the sodium lose 1 electron, became a positive ion. Yes, positive ion, and the positive ion of neon, of the positive ion of sodium has the same electron structure of the neon. Then the positive ion of sodium has the same electron configuration of neon. Yes, we can see here. Then here we can see the sodium. The sodium has 11 protons, but because lose 1 electron, then now has 10 electrons. And then if we just do the math, we will have 1 positive. And this is why sodium is positive ion. Now we want to talk about the isotopes. Isotopes are atoms of an element must have the same number of protons. Then we had atoms of an element, but all of them had the same number of protons. However, the number of neutrons may vary. Yes. This is one example. We have 3 different isotopes of hydrogen. Because it's hydrogen, the number of protons must be the same. We had 1 proton, 1 proton, 1 proton. But what happened is the number of neutrons change. Then in this case, we had 0 neutrons. In this case, we had 1 neutrons. In this case, we had 2 neutrons. Then we had 3 different isotopes for hydrogen. Then with the atoms of an element have different number of neutrons, this we call isotopes. Then we had a chemical symbol to identify the isotopes. This is the chemical symbol. This is the symbol for the element. The number in the bottom indicates the atomic number or the number of protons, which is the same. Yes. And the top number indicates the mass number. Remember, the mass number equals to the number of protons plus the number of neutrons. And in this case, we had 1 proton, 0 neutrons, then the mass number is 1. In the second case, we had the atomic number is 1, is in the bottom part, and in the top part, we had 1 proton plus 1 neutron is 2. This is why we had number 2 here. In the hydrogen 3, hydrogen 1 is the number of protons or the atomic number, and in the top one, we add the number of protons plus the number of neutrons, and we have 3. Yes, 1 plus 2 equals 3. In this example, we want to identify the number of protons, the neutrons, and the electrons in the following isotopes. Then let's identify the protons using the E letter, neutrons just using N, and the electrons, let's use E, like that. Then we want to find how many protons, how many neutrons, how many electrons we had in each of these isotopes. And let's start with this, the nitrogen. In case of the nitrogen, then 7 corresponds to the atomic number, and we know the atomic number equals to the number of protons. Then we can say number of protons is 7. The number of the electrons, because this is non-ion, the number of electrons equals to the number of protons. And we had 7 also. And the number of neutrons, and we can see, just to review, the mass number equal to the number of protons plus the number of neutrons. Then if we want to calculate the number of neutrons, just what we need to do is subtract the number of protons from the mass number. Then the number of neutrons equal to the mass number minus the number of protons. And what we had to do is just subtract 16 minus 7 to get the number of neutrons. Mass number minus number of protons minus the atomic number. And will be 16 minus 7, which equals 9. Let's solve the next problem. We had copper. Then copper 2963. Then in this case, the number of protons equals to 29, which is the atomic number. It's 29. The number of electrons equals to the number of protons, and will be 29 also. And then we had neutrons will be just 63 minus 29, which is equal to 34. In the last problem, we had uranium. We had the isotope of uranium, which is 92 to 30. And in this case, we had the number of proton is 92. Number of electron is also 92. For the neutrons, we had 230 minus 92, which is equal to 138. And let's now review some concepts. And an element is composed of atoms and that have the same atomic number. Then if we had an atoms of hydrogen, the atomic number will be always 1. If we had an atoms of copper, the atomic number will be always 29. Or aluminum, the atomic number will be always 13. Now, a molecule is a particle that is composed of 2 or more atoms that held together by chemical bonds. For example, we had the molecule for water or carbon dioxide. And the isotopes, now we know the isotopes are atoms of an element with identical chemical properties but different masses due to the difference in the number of neutrons. Then isotopes, they have the same atomic number because correspond to the same atom, but they have different number of neutrons, and this is why they have different atomic masses. Also, now we know when an atom or molecules gain or loses an electron, it becomes an ion. And we have 2 different kinds of ion. Can be cation if the elements lose an electron and therefore has a positive charge, and can be an anion if the elements gain an electron and therefore has a negative charge. Yes. And we have 2 different kinds of ions. Can be ions that have positive charge or can be ions that have negative charge. And why is how the elements joins to form compounds? And what happens is if we had the molecules, we had the elements that react to form a new substance with new properties, then when they react, there is some change in matter, and this change in matter we call chemical reaction. Then we can define a chemical reaction as a change in matter in which different chemical substances are created by breaking or forming chemical bonds. Yes. And when the ions or the atoms or the molecules, they react to form a new compound with the new properties. Then sometimes if the elements they are stable, which is the case of the noble gases, then some of them they can occur as single atoms, and this is called monoatomic. Yes, this is the case of the helium. In some cases, to be more stable, then they can occur as diatomic molecules. That is the case of oxygen and is the case of hydrogen. And in some cases, like triatomic, and this is the case of the ozone, in which 3 molecules react to form the new compound, which is ozone. Then how these ions, how these molecules stick together, this happens because of the chemical bonds. Then what happens is during the chemical reactions, atoms gain or lose electrons, and the reason they lose or gain electron is to fill the outer shell and to be stable as the noble gases. What happens is when the chemical reaction occurs, the there is attractive force that holds the atoms together. Yes, this is why they stick together to form a new compound. Yes. And why they stick together? Then there is different ways that reaction can happen. Yes, one is the ionic bonding. Then in case of the ionic bonding, the electrons transfer from one atom to another atom. Yes. For example, we had here lithium. Yes, lithium has one electron in the last shell, and fluorine has 7 electrons in the last shell. And to be stable, lithium transfers 1 electron to fluorine. And now lithium is stable, it's like helium, and fluorine gain 1 electron to have 8 electrons in the last shell to be stable. Now, if the lithium get 1 electron, then the lithium became a positive 1. But the fluorine gained 1 electron, now became a negative ion. What happened is now one part is positive, one ion is positive, the other ion is negative. Remember, if we had different unlike charges, they attract. Then they attract, yes, they attract, and then there is, because of one is positive, the other is negative, this difference in charge results in an electrostatic force is developed. And that force is that keep these two ions together. And always, in case of the ionic bonding, this happens between metals. In this case, lithium is the metal, and the non-metals, in this case, is the fluorine. In the covalent bonds, the atoms are shared. Yes? And again, the reason the elements share the electron is to have similar structure as the noble gases. Yes, this is why they react together. Yes, to achieve the noble gas electron structure. Means they want to have an electron in the last shell. This is the reason. Here we had carbon. Carbon has 4 electrons in the last shell, and hydrogen just 1. Then hydrogen share with the carbon the electron. In this way, each of these hydrogen now has 2 electrons, and they are similar to helium, the structure of helium. And now carbon has 8 electrons in the last shell. Yes, share the electrons with hydrogen, and hydrogen share the electrons with carbon. And in this way, both are stable. Then in ionic bonding, what happens is the electrons are transferring, but in case of the covalent, the electrons are sharing. Then ionic bonding, transfer, covalent bonds, share electrons. Then we will focus mainly in the ionic bonding, means when the electrons are transferred to form a new compound. Then when the compounds are held together by ionic bonds, it are called ionic compounds. And mainly this happens between the groups of elements. This group of elements, the metals, they occur mainly in the metals elements and the non-metal elements. This group, yes, is the possibility to form ionic compounds. And here we had one example. Here we had sodium, and we can see sodium is in the first group. This is why sodium has 1 electron in the outer shell. Yes, 1 electron. But chlorine chlorine is in the group 7. This is why chlorine has 7 electrons in the last shell. And to be stable, what happens is sodium is easier for sodium lose 1 electron to be similar to neon, to be stable with 8 electrons in the last shell, and lose 1 electron, and chlorine gain 1 electron to be similar to argon. Yes. Now what happened is sodium lose 1 electron, became a positive ion. Yes, and this is the positive part. Yes, this is the positive part. Then chlorine will be gain 1 electron and became a negative ion. Yes. Then because these are unlike charges, they attract together and they stick together by electric force. Yes. That electric force that keeps sodium and chloride together, and then they form sodium chloride. Yes. This is the new compound with 2 different properties. Sodium chloride is the same as the salt we use to cook. Yes. This is the same thing, the sodium chloride. Then we can represent the same thing using the dot notation. Yes, using the dot notation. Then sodium has 1 electron in the last shell, yes, in the outer shell. Chlorine 7 in the outer shell. Then they react to form a new compound. Yes, and when they react, then sodium became a positive ion, and chlorine now with A is lose the electron. This is why there is no red dot here, lose the electron, but chlorine gain 1 electron to become a negative ion. Yes. Here is how we can represent the same reaction using a dot notation. If we had an ionic compound, then we want to know how we can write the formula of that compound and how we can write the name. Then the formula of the compound describes what elements are in the compound and in what proportions. Then let's first talking about the formula. What are the rules? Then for the formula, first we will write the symbol of the positive ion, means the metal. And this is the first we want to write. Then we want to write, after that, we want to write the symbol of the negative ions on the non-metal ion. And also we can use subscripts, and that subscripts indicate the number of ions needed to produce an electrical neutral compound. And always when we form a new compound, then that new compound must be neutral. Then we want to adjust the subscripts, yes, to make sure the new compound is neutral. And now let's write the formula in this case. Yes, in our previous example, we had sodium chloride. Then because sodium is the metal, then we will write first sodium. Yes. Yes. In this case, sodium is the metal. Remember, always the positive ion is the metal, and chlorine is the non-metal. Then always the first is the symbol of the metal. Then this is why we had first sodium, and then we had the symbol of the non-metal, which is chlorine. And one important thing in the formula, we don't want to add the charges. We don't want to add this positive one or negative one. Just when we want to write is the symbol of the element. As we want just to write the symbol. We don't need this. We don't need the charges of the ions. Another important thing we need to check if the new compound is electrically neutral. And you can see here we have sodium is +1, yes, the charge for sodium is +1, and the charge for chlorine is -1. Then -1 and +1 and -1 is neutral, yes, it's 0. And this is why we don't need to write any subscripts here, yes, because it's neutral. Yes, we need one sodium, one chlorine to get neutral compound. Now the next thing we want to, this is how we can write the formula. Now how we will write the name of the compound. Then first we will write the name of the metal. Yes, just the name of the metal. In this case the metal is sodium, then just we write sodium. Then we write the name of the non-metal, which is chlorine, but just we want to change the ending of the non-metal by "ide." Yes. Then we want to write sodium and not chlorine, chloride. Yes, chloride. And the name of this compound, yes, this compound of this formula is sodium chloride. And let's review again how we can write this one. Yes. Then we had sodium, we already did this one, sodium chloride. Let's go with the next one. Then we had magnesium. Magnesium is in the second group, yes, then has 2 electrons in the last shell. This is why magnesium has here 2 dots, you see, 2 dots, because it's in the second group. It's here. And oxygen is in the group number 6. You see, always we had one from the metals and the other is from the non-metal side, as in this case is the oxygen. And oxygen has 1, 2, 3, 4, 5, 6 because it's in the group number 6. Then to be stable, what happened? Magnesium will be transferred 2 electrons to oxygen. This is why we don't have here any dot. Yes, just transfer 2 electrons to oxygen. Now magnesium became +2 because magnesium lose 2 electrons. And you see magnesium is +2. Yes, magnesium is +2. It's in the second group. But now oxygen has 8 electrons, is stable. Yes, oxygen now is like neon, is stable. Has 6 electrons in the last shell. Because oxygen gained 2 electrons, became a negative ion, and because gained 2, this is -2. This is -2. And the next thing we want to check if we had neutral compound. We had +2 here, we had the -2. Yes, the total charge for the positive ion is +2, for the negative ion is -2. +2 minus 2 equals 0. We have neutral compound. Then just we need to write, to get neutral compound, just we need 1 magnesium and 1 oxygen. And this is why we had here, we don't need any subscripts. And now we had 2 oxygens. Sorry, we had magnesium +2, oxygen -2. Now let's write the formula. Always we want to write first the metal, which is magnesium in this case, or the positive ion, always is the first. And then after the positive ions, we want to write the non-metal, the symbol for the non-metal. In this case is oxygen. Yes, then magnesium, oxygen. And now we want to write the name of this. Then just we write the name of the metal, which is magnesium. And then we don't want here oxygen, just we change the termination for oxide. Yes, and the name of this compound is magnesium oxide. Let's try the last example. In this case, we want to see what compound we can get if calcium reacts with chlorine. Yes, then calcium is in the second group, and this is why we had two electrons in the outer shell. Chlorine is in the group 7, then chlorine had 7 electrons in the outer shell. Then what happened is, if calcium, chlorine to be stable need just 1 electron to complete 8 electrons in the outer shell. And if calcium transfer 1 electron to this one, yes, let me write here, if calcium transfer this electron to this one, what happened is chlorine will be happy because now chlorine has 8 electrons in the left shell, but calcium need to lose 2 electrons to be stable. Yes, calcium need to lose 2 electrons to be similar to argon. Then what happened is, in order to be stable, then we need another chlorine, yes? Then this is why we need another chlorine too. In this way, calcium can transfer the other electron to the other chloride. Then to form this compound, we need 2 chlorine. And also, in order to have a neutral compound. Yes, in this case, what we can see is we had 2 carbons, 2 calciums, sorry, 2, positive 2, in case of the calciums, yes. But in case of the chlorine, we had negative 1 here, negative 1, and finally we had negative 2. And in this way, we had neutral compound, yes, positive 2 minus 2 is 0. And this is why in this case we need 2 chlorines. And how we will express this one in the formula? Then for write the formula, first the metal, which is calcium, yes, is this one, then the non-metal. But because we need 2 chlorine, we will write 2 here that indicate we need 2 chlorines. And another thing is just to remember, we don't need any charge in the formula. You see, we don't have positive 1, negative 2, no. We don't, just the symbol of the element. Now the name. For the name, we just write the name of the metal, which is calcium, and then chlorine, but just change the N by ide. Then calcium chloride will be the name of this compound. In this table, we had the common ions of some representative elements. Then we had the monatomic cations, which correspond to the metals, this part, and monatomic anions, which correspond to the non-metals. And how we will know what is the charge for each of them? Then we will use the periodic table to do that. And let's just quick review. As we know, always the metals, they are positive ions. The reason is they lose electron. For example, the first group, they lose electron and became a positive 1, as this is the case of lithium. Now we had also the case of sodium, potassium. In the second group, they had 2 electrons in the outer shell, then they lose 2 electrons to become a positive 2 ion. And all this, they are positive 2, they are ions. The ion is positive 2. This is the case of magnesium, calcium, barium, aluminum, because aluminum is in the third group, then aluminum lose 3 electrons and became a positive 3 ion. Yes, and all in this group they are positive 3. But in the other part we had the non-metals. And what happened with the non-metals? They, for example, in group 7, to get 8 electrons in the outer shell, they need to gain 1 electron. Because they gain 1 electron, they became negative 1. And this group, all this group, okay, negative 1. This group, because they had 6 electrons, they need to gain 2 electrons. Then they became negative 2. Then, let me just delete this part. And in the equation sheet, you will have this table. And in this table, you see the numbers on top. They indicate what is the chart for this each group. And you will need to know this one when you need to write the formula, or you need to write the equation for the reaction. You need to know this chart. And you see, you don't need to really memorize or use this table. Just you will have all the information here in the table. There's all this group. They are ions +1. The chart is +1. This group, the chart is +2. This group is +3, and these are -1, -2, -3. Yes. These are the metals, and these are the non-metals. Yes. And usually this group react with this group to form a new compound. In this problem, we want to use the electron dot notation to predict the formula of the compound formed when aluminum combines with fluorine. And aluminum is here, yes, aluminum combined with fluorine. And because aluminum is in the third group, we know aluminum has 3 electrons in the last shell. And let's write this one in dot notation. Let's use the dot notation to represent that. And aluminum 1, 2, 3. Then we had fluorine, and fluorine is in the group 7. Then fluorine has 7 electrons in the last shell. And let's represent this one using dot notation. 1, 2, 3, 4, 5, 6, 7. Then in order to be stable, then aluminum needs to lose 1 electron, 3 electrons, and fluorine needs to gain 1 electron. And let's try to do that. Then this aluminum transfer 1 electron to fluorine. Then what happened is fluorine is stable because now fluorine has 8 electrons. It looks like neon. But what happened with aluminum? Aluminum needs to lose 2 more electrons. And in order to do that, we need another fluorine. Yes, we need another fluorine, and then we will write this one here. And transfer this one here. But still, aluminum needs to lose 1 more electron. Then we need another fluorine. Then fluorine has 7. This here. Then now we can write the equation for this reaction. Yes, aluminum lose 3 electrons, then became +3, and this is what we had here. Yes, +3. Yes, this is we expected. We had +3 here, plus fluorine, and each fluorine now is -1. Yes, because gain 1 electron. Yes, it's -1, -1, -1. But now we have three fluorines, and the way we can write this one is we will write this 3 here to indicate in order to form the compound, we need 3 fluorines. For 1 aluminum, we need 3 fluorines. And now the next thing we need to check if we had neutral compound. Then from the positive, from the metal we had positive 3. From the non-metal we had negative 1, but we had 3. Then 3 times negative 1, we had negative 3. This 3 we had here times negative 1 is negative 3. Now we had neutral compound. And now we can write what is the formula. And the formula will be first the metal, yes, first the metal, and then the non-metal. And because we need 3 fluorines, what we will do, we will use the subscripts to write. Then the formula for this will be this is when we combine aluminum with fluorine. This is the compound we will. Let's write the name of the compound. Then to write the name, we will write just the name of the metal, which is aluminum. And then we need to write the name of the non-metal, and we need to change the termination for "ide." Then we had fluor, but we change the termination for "ide." Then it's aluminum fluoride, as this will be the name of the new compound. And this is the formula, this is the name. Now let's talking about a little bit transition metals. Then in case of the transition metals, which are the elements are in the middle of the table, this doesn't belong to the A groups, and this then these elements don't belong to the A group. And the thing is, these elements, they have more than one charge. Yes, for example, chromium has 3 different possible charges. Manganese has 3 different possible charges. Iron has 2. Cobalt has 2. Then in this case, we need to do something when we name the compound. We need to do something to know if the iron is in the compound is positive 2 or is positive 3. Then if any transition metal is in the compound, yes, we need to be careful to write the name in the correct way. Then what is the rule? First, we will write the name of the metal, but because, for example, in case of the iron, can be +2 or can be +3, to indicate that we will write the Roman numbers in parentheses to indicate the charge number. For example, if it's iron 2, we will write in this way. Yes. We will write the name of the compound and in parentheses the charge. Yes. Iron +3 will be iron 3. And then we will write the non-metal, and we know the ending of the non-metal is changed by "ide." Yes, this is the way we will. This is the way we will write. We will write the name of the. If in the ionic compounds we have transition metals, then you don't have to memorize this one. You will have this table with you, yes, if you need this information. Also, you can analyze the formula of the compound, and you can get what is the right charge for the metal. And we had what is the name of this compound, if that compound that had this formula, then we want to know what is the name. And let's write just the equation. Then we had iron plus, let's see if I had here, yes. Then here we had the iron and we had the bromine. Yes, bromine is 35. Then bromine is in the group 7, and we know bromine must be -1. Yes, bromine has 7 electrons in the last shell, gain 1 electron and became -1. But you don't need, you just have here the charges, and now you understand why we had here -1. And we know that bromine is -1. But what happened? We had 3 bromines. Then to indicate this 3, remember, we will just write this one here. And let's see what is the charge for the negative ion. Then we had 3 minus 1, we had -3 on this side. In order to be neutral, this compound, the ion must be +3. The ion must be +3. And we know the ion in this case is +3 is the only way we can get this compound. Then really, you don't need really to have this, to memorize this one, because you can get, if you analyze the formula, yes, if you write the equation of the reaction, then you can get what is the charge for each of the ions. But also you will have this with you, yes, in the final you will have this table is in the equation sheet. Then you can always check what is the charge for each ion. And now let's write the name. Then according to the rule, we first will write the name of the non-metal, of the metal, which is iron. The charge for the iron is 3. Then we'll use this one in parentheses. Let's write this one here. That's why in the way it's in the table. As they write something like 1, 2, 3. Yes, iron 3. And then the name of the non-metal, but we change the termination for I. And then this will be iron bromide. Yes, this will be the name of this compound. And we have here the same thing. And for now, let's practice doing a few more examples. We want to write the name of the following compounds. And it's a good idea always write the equation. To write the equation, we will use this table. And if you need, you will have this information also. Yes, you want to have this information just in case. But I think just with the periodic table I provide in the equation sheet will be enough to solve the problems you need to solve. And let's try to find the name of the compounds. The first one, when the lithium react with fluorine, then let's see what is the name. Then what happened? Let's write here the number 8. We had lithium plus fluorine. And let's check what is the charge for lithium. Lithium is the first group is +1. Yes, +1. Fluorine is in the 7th group and is -1. It's -1. It's -1. And now we can see in the metal side, in the positive ion, we had +1 here. Finally, we had -1. This is neutral compound. Then we don't need to do anything, just we need to write the final formula, which we know, yes, is this one. Then we can just write the name of the compound. Then the name will be the name of the metal, which is lithium. Then the name of the non-metal, but we change the termination. Yes, and we do that. Yeah, let me write correctly. Fluoride, yes. And lithium fluoride will be the name of that compound. Then let's try the second one. We want what is the name of the compound if lead react with fluoride? Then we have lead here plus fluoride. Lead is the transition metal, and lead is 82. Let's see, where is lead? Here. And lead is here. And lead is not exactly the transition metal, but lead has more than one charge. Yes, lead can be positive 2 or can be positive 4. And in order to write the name, yes, we need to know if the lead in this case is positive 2 or is positive 4. And let's see. Then we had 2 fluorines. You see this 2, then we will write here this 2. And we know the fluorine is -1. Yes, here is fluorine is -1. It's here. And this one is -1. Then what happened on this side? Yes, we can get the total charge for the negative ion. 2 minus 1 is -2. In order to be neutral and to form this compound, this lead must be positive 2. Yes, it's the only way we will get neutral compound. Yes, lead must be positive 2. Then we know in this case lead is 2. Then the name of this compound, just will write first the name of the metal, will be lead. Will be lead and will be 2. Yes. And then we write the name of the non-metal and we change the termination. And this is the answer for the first one, and this is the answer for the part B. Now let's try the part C. And in this case, they give the name of the compound, and we need to find the formula. Yes, and we had potassium bromide, and we need to find what is the formula for this. And let's write here. See, potassium is K. Yes, potassium is K, and this must be the metal because it's first, and then we had the bromide must be the non-metal. Yeah, we'll write this one. And let's check what is the charge for potassium. Potassium is in the first group, is +1. We know potassium must be +1. Now bromine is in the group 7 and is -1. Then we can see this, the positive ion is +1 and the negative is -1. They are neutral. Then we don't need to do nothing, just write first the metal and then the non-metal symbol. Yes, because we want is the formula. And then this is the answer, and this is the formula for potassium bromide. Yes, this is the answer. Now let's try number D, which is copper 1. Yes, copper 1 is this one, copper 1, and we know the charge is +1, and sulfide. Then we need to check that. Let's try to write the equation, we had copper, and we know it's +1 because it's in the name is telling it's 1. Plus sulfide. But let's see, sulfide is here is 16 and sulfide is -2. Yes, it's in the group 6, and this is why it's -2. And we need to write here -2. Now what we had is on this side we had +1, but on this side we had -2. But we need neutral charge in order to get a compound. Then the only way we can get neutral charge is we need to write 2 here. Yes. 2 coppers. Because if we multiply 2 times +1, we will have +2. And in this we have 1 times -2 will be -2. And we had neutral compound. Then let's write now the formula. First we need to write the metal. Because we had 2 coppers, we will write here 2 to indicate. In order to form the compound, we need 2 ions of copper and 1 sulfur. Yes. And the formula in this case will be this one. And this is the formula for copper 1 sulfide. Yes, copper 1 sulfide. And let's go to the next one. Now in this case we had the polyatomic ions. And polyatomic ions are the group of atoms that act as a single unit in ionic compound. Yes. Then instead, usually most of them are negative, you see. Then it will be like the non-metal part. Yes, this will be add as the non-metal part. Then they react with the metals to form a new compound, and we can consider this one as one unit. Yes, like a single unit. Yes, we can when we write the formula, or when we write the equation to get the compound, we can think this like one unit. And in this case, for example, we had acetate, which is -1. Yes, yes. Only I think ammonium is +1 in this case. Will be like the metal part. And we had a list of all these polyatomic ions. Then how we will write the name if the polyatomic ion is in the compound? Then first we will write the metal with Roman number in parentheses to indicate the charge if it's needed. If not, just we write the name of the symbol for the metal. And then just we write the name of the polyatomic ion. Yes, what we write first? The metal. If it's needed, we will use Roman numbers in parentheses, and then we'll just write the name of the polyatomic ion, which is this in this list. Also, in the test, just you will need these polyatomic ions, while I add in the equation sheet. And you don't have to worry for all this long table in the test. You will use just these polyatomic ions are in the equation sheet. Yes. Let's try to write the names of some ionic compounds in which polyatomic ions are involved. And we will follow this rule. First the name of the metal and then the name of the non-metal ion. And in this case, we had sodium. Then this one we will check in our list. Then it's OOH, then it's hydroxide. And it's here, yes, it's hydroxide. Then the name of this one will be sodium hydroxide. It's just the name of the metal and the name of the polyatomic ion. Then in this case will be sodium hydroxide. In the second case, is the name of the metal, which is potassium, and then the name of the polyatomic ion, which is hydroxide, then will be potassium hydroxide. Here will be sodium, and then we need to find this polyatomic ion in the list, is this one, which is nitrate. Yes, nitrate, and then just we write the name sodium nitrite. Yes, sodium nitrite. Then we had here sodium. As we don't take into account these numbers, nothing, just if here is sodium, we will write sodium. And then we need to find the name of this polyatomic ion, which is carbonate. Yes, here is carbonate. And with sodium carbonate. And the last one will be calcium. And then we need to find the name of this polyatomic ion, which is nitrate. Yes, nitrate. And it's here. And the name of this will be calcium nitrate. Yes. And we have there. And it's similar, just, and again, you don't need to memorize this one because the names, you will have the names with you. Yes. And let's try now to write the formula of these compounds. Yes. And to that we will use the information we know. And let's see. We have the periodic table just in case of we need, and you will have this periodic table also in the test, the same periodic table. And lead we know is 2, and then we had nitrate. Yes, lead nitrate, and we need to here. Let's go back here, and we had this is the polyatomic ion. Yes. And let's start writing the equation for number 1. Yes, for number 1. It's lead. In this case, lead is positive 2. Remember, the metal is always positive. And then we had nitrate, which is this one. Yes. And the charge of this one is -1. Now we need to check. Let me try to write better this one. We need to check if we had neutral charge. Yes, we need to check we had neutral charge. And on the metal side we had +2, but in the polyatomic ion we had -1. And we need to get neutral charge, and what to do is just we need to write here. We need 2 nitrate. Yes, we need 2 nitrates. And now let's write the equation. Let's write the formula. Now we had neutral. Yes, +2. 2 minus 1 with -2. We had neutral compound. Yes, now we need just to write the formula. Then first the metal, and then we need to write the polyatomic ion. We don't need to write the charges, remember, in the formula, but because we need 2 of this one, we will indicate that we need to write 2 here to indicate we need 2 units of nitrate. And let's try the number 2, which is potassium chromate. And for potassium, let's see what is chromate is here. Yes, chromate is here. And let's see potassium. Potassium is in the first group, then it's +1. And let's try to write this one, potassium potassium is positive 1, plus chromate, and chromate we will see here, where is chromate, is this one. Negative 2, I think so, yes, chromate is negative 2. And the next thing we need to check if we had neutral compound. Yes, on this side we had negative 2, but on this side with positive 1, but we need 2. Then what to do is just we write 2 here. Yes, and 2 plus 1 will be positive 2. Now we had neutral compound. And now we had neutral, just go ahead and write the formula. Then potassium first, because it's the metal. Because we need 2 potassiums to get the neutral compound, we will write 2 here, and then just the polyatomic ion. We don't need the charges, yes, in the formula. This is the answer. For number, the last one, aluminum acetate, and aluminum acetate. And less acetate is here, yes. And aluminum, what is aluminum is just here, yes, and it's plus 3, yes. Aluminum is plus 3, then we will write here plus 3. And then we need acetate will be, and let's write the complete unit, and the complete unit is negative 1. I will write here the formula. I don't have enough probably space here. Then aluminum, we had in the metal side we had positive 3, but here we had negative 1, but we don't want negative 1. We need neutral compound, and we need to write 3 here. 3 minus 1 will be negative 3. Now we have neutral compound. And to write the equation, what we need to do is just using this equation, we will write, let's see if I can write here. We have aluminum, and then we had the acetate. Because we had 3, we need 3 units of this one, and we will express like that. And this is the formula for aluminum acetate. In some books, some cases, you also, yes, you multiply this one, 2 times 3 is 6, and in some cases you can find the equation like that. 3 times 3 is 9, oxygen 2 times 3 is 6, can be like that also, and it's also correct. Yes, can be either this way or this way, both are correct. Let's solve a few more problems in which the polyatomic ions are involved. And in the first part, we want to name the following compounds. We want to name this compound, and we want to name this the other one. What I suggest you always, even if it's just to name, I suggest you to write the equation for this compound. Right? What is the reaction that occurred for this compound? And let's write for number A, what is the equation? A we had sodium. Let's write just first the elements, the ions. We had sodium. Sodium react with this is sulfide. It's here. Yes, it's here, and it's negative 2. Yes, sulfide is negative 2. And sodium is in the first group, then sodium is positive 1. It's on a space here. Sodium, we know sodium is positive 1. Let's see if I had the, yes, sodium is in the first group, and it's positive 1. Yes. Then now we need to check if we had neutral compound. Yes, then we need 2 sodiums. Yes, we need 2 sodiums, and this is why we had 2 sodiums. Yes, we had 2 sodiums and 1 sulfide. Yes. And it's important because sometimes, especially in the case of transition metals, you need to know the charge. Then I suggest you always write the equation to form the compound. Then the name in this case will be the name of the metal, which is in this case sodium. And then the name of the polyatomic ion in this case will be sulfate. Sulfate. And this is the answer. And let's try number B. Number B, we had copper. Then we start with copper. And then hydroxide. Hydroxide, let's see what is the charge for hydroxide is -1. Let's see, hydroxide is -1. We'll write here -1. Now we know, according to the formula, we had 2 hydroxides. We need 2 hydroxides to form the group. And here we need 2, yes, because this is we had here in the formula. Yes. Now, copper can be +2 or can be +1. Then, but now with the formula, with the equation, we will know if the copper is +1 or is +2. Yes, let me write better this one. This is -1. Then here 2 minus 1 is -2. Then in order to be neutral, the copper must be +2. Yes, must be positive. It's the only way we can get neutral compound. Then this is the only way we can get the formula we had here is copper, and we need 2 units of hydrogen. Yeah. Let me write better this one. We had copper and 2 units of hydrogen. Then now we can write the name. Yes, it will be copper. But we know copper must be 2. Yes, then this is we will write using the Roman number in parentheses. Copper must be 2. And then we had hydroxide, which is the name of the polyatomic ion. Hydroxide. And this is the answer. For the other 2 problems, we want to write the formula of the following compounds. They give the name, and we need to write the formula. In this case, we must write the equation. Yes, not the only way we can get the formula. Then number C, we had calcium carbonate. Then we had calcium here. Then we had carbonate. Then we will check here with the carbonate. Yes. Carbonate is -2. Calcium, if you don't remember in what group is calcium, which is in the second group, sorry. Here is calcium is in the second group is +2. Yes, calcium is +2. And we will write here +2. Then this is +2, this is -2, is neutral. Then we don't need to multiply by any number, just we write the symbol of the metal and then the symbol of the polyatomic ion without the charges. This is the answer. Then let's try D. D, we want calcium phosphate. Yes, calcium give some space, calcium, and now we know calcium is +2, then phosphate is -3, yes. It's -3. And we need to check if we had neutral compound, if these two, if the calcium react with phosphate, if we had neutral compound. And on this side we had +2, and in this side we had -3. And what happened in this case is that it's not easier to guess what is the number, like is, for example, in this case that we know we need 2 here. And what to do in this case, you can use just the cross product. You see, if 3 is here, you need to multiply the first by 3, and if this is 2, you need to multiply the second by 2 to get neutral compound. Also, you can also think in another way. You need the least common denominator between 2 and 3, and in this case is 6. Then you need to get 6. Then for what number we need to multiply here to get 6 by 3? For what number you need to multiply the second term to get 6 by 2? Then either way works. And maybe cross product is easier. Then you multiply the first by 3 as cross product. You multiply the first by 3, and you will have 3 plus, and the second by 2. Then in this way you will get here 3 times 2 is +6, 2 minus 3 minus 6. Now you had a neutral compound. Then now we can write the equation. Yes, now we can write the formula. Then in order to form this compound, we need 3 units of calcium, and we will indicate that. Why we need to write 3 here, and we need 2 units of phosphate, and the way we indicate that, we will just write here. And this one is the answer in this case. This is all I had to discuss for today.